So in this problem, I have to remove duplicates from sorted list and given the head of a sorted linked list, delete all duplicates such that each element appears only once, and then return the linked list sorted as well. So if there is 1, 1, 2, then remove if the node is getting duplicated, then make it appear only once. So 1 and 2. Similarly, here 1 is duplicated and 3 is duplicated. So make it appear only once. Once that means 1, 2, and then 3, and we should make sure that it is uh, you know in ascending order as well. This is because the given list is already sorted, so there is no any problem for that. We will just see one by one. And if you see here that number of nodes in the list is in the range 0 to 300. It is not much, so I think we can go with recursive approach because if suppose if range was maybe of range 5000, then in that case recursive approach would have shown stack overflow. Okay, so in that case, we would have used iterative solution. So let us move on with the recursive solution. So what I'm gonna do, our question is 1, 1, 2, 3, 3. Okay. So 1, 1, 2, 3, 3, and then null. Okay. So in recursion, what we do is suppose I have a condition. Okay, and that condition is for terminating the recursion, and I have a recursive line here with in which we are calling method the same method but with updated parameters. And then finally, in this is first one, this is second one, and this in third layout we usually return something which we want this recursive call to return. Okay, similarly, let's see about this question. Here what we have, I want to link every node. No, so suppose head is here, so head dot next is equal to method call with updated parameters. Head, now what will be the updated parameters? Actually new head, which will be this one, head dot next actually. So 1. Now again, what we will do, we will point next reference of this node to method call similarly with updated parameters 2. Remember that we are not interested in finding what these methods are returning. We are now just only interested in how the flow of control is working. So now again we will write 2 dot next is equal to method call with updated parameters 3, and similarly inside this method also we are calling the same method, and now head is 3. 3 dot next is equal to method call head dot next, which is here 3. Again we are okay, huh? So this 3 is this one, and inside method call we are pointing 3 dot next. Okay, so let us start from here. Okay, so 2 dot next is equal to method call 3, and then 3 dot next is equal to method call 3. Okay, now what we do here, again I will link. Okay, this 3 is this one actually, I believe. Okay, yeah, this 3 is this one, and you know what, in this what this method will return, this method will return something which we have written in our code. Okay, so in the first line, whatever code which we have written in the first line of our method, uh, that is usually for ending the recursion. So we will use, suppose this is head. Okay, no, it is not head. We should not suppose this is actually head. So if head is null or head dot next is null, then just return head. In this case, head dot next is null, so just return head. So actually, we are writing the all linkages here. So 3 dot next. It is what this method is returning, and what is it? It is linking with. It is linking with 3. So just link it with 3. Okay, 3 is. So we are more interested in finding what the method will return, and that only depends on the condition. Okay, for example, we are here, we are at this point 3. Okay, so what is this 3 pointing to? This 3 is pointing to this node, and there is one condition that if head dot next is null, then just return head. So this method is returning 3, and which is pointing to null, and then this we have returned 3 pointing to null, and this is being connected to this 3 because this arrow means connected. So just connect 3 with this 3. Now we will return to this recursive call method at this point. Okay. Now what does this line indicate? This line indicate the point at which we are calling the recursive function again. So below that recursive call, we will add one condition that if this head is equal to head dot next, then just return head dot next, and then it will get skipped. Okay, and then finally connect it with this two. So in this case, we have this three. This three is head now because we are moving backwards. So this three is head, and we are comparing that if this head is equal to head dot next. Obviously, head is equal to head dot next. Then what you have to return? Head dot next. We will return this, and we will finally connect it with this two. So what we have, this three will be removed, and then we will connect this two with this three. Okay, now just move backwards. Now our head is here, and then we are comparing actually that if this head is equal to head dot next. Now let's check it. This is head, whether this head is equal to head dot next. See this, compare this both. Absolutely not. Then in that case, just return head. Okay, so just return head, and whatever this will return, it will be connected to this one. So just connect it two with one. Simply, our pointer will move to this. So our next pointer will point to this one. Okay, and then let's compare. If if head is equal to head dot next, no, then just return this one. Okay, so this method will return one, and it will connect it with this one. So just connect it. One is connected with this one. Now finally, before returning, what is that we want, which we have more concern about. We have more concern about the condition which the whole method is returning. What the whole method is returning, that if head is equal to head dot next, then just return head dot next. So we will return this part of the linker list. Okay, so what we have, one, two, three, and then null. Done. Let's move to the coding part. Okay, we have, let's see. So let's give a recursion ending condition that if head is equal to null, and head dot next is equal to null, then just return, sorry, head. Simple. And then let us move to the condition which require the recursive function calling. Okay, so head dot next is equal to method call delete, sorry, delete duplicates with updated parameters, head dot next. Okay, and then finally we will give condition that if head is equal to okay, head dot, okay, sorry, head dot val, actually we are comparing values. Head dot val is equal to head dot next dot, sorry, val. Then in that case, just return head dot value, or head dot okay, head dot next dot value, because in this case equality matches. Okay, that means we have found the duplicate. So skip the first one, and then connect it with the other one. So else, you know what, just don't give else, just return head dot value. Simple. I think this method is recursion ending condition. This method is recursion calling condition. If head dot next, connect the head dot next with the method call with updated parameters, and then if head dot val is equal to head dot next dot val, then just return head dot next dot val. Else, in every case, return head dot val. Okay. Uh, okay, just check the test case first. So what is this? Int cannot be converted to list node. What is happening here? List node. Okay. Okay, what I'm writing here. just return next. Why? Because this method is accepting only node, not integer. Okay, just run it once and check for any kind of type or something. So null point exception just give here or. You know why? Because if either any one of the condition is true, then just move ahead. Otherwise, look. Otherwise, it will not return head in either of the cases. In our drawing explanation, okay, and then network. Oh my god, what the heck? Network's good, bro. Just do it. Let's see. Okay, accepted. Now let's submit it. Oh no, what the heck? Network is trying to do with me. Let's submit. You have attempted to run code too soon. Please try again few seconds later. Okay, bro. Why are you not accepting my solution? Okay, just completed. See, we have no any problem with time, but actually, it is quite good with memory also. It is not so much good. Why? Because we have applied recursive algorithm. Why we have applied recursive algorithm? Because we had less number of nodes. If you see the best solution, I think that they are also doing the same thing. But no, they are not doing, applying a recursive approach. Okay, let's end this today. F